Okay, so we were on 9, 10, and 11C. We had just found 9C, the energy of the photon that was needed to jump an electron from the E equals 2 level up to the E equals 4 level. And then 10C wanted to know its frequency, so using E of the photon is equal to HF, so F is equal to EP over H. So just like we did in all the other ones, take your 2.55 electron volts and multiply it by the 1.602 to the negative 19 joules seconds and divide it by 6.626 to the negative 34 joules per electron volt, and this one's joules seconds. And when you do, you should get a frequency for C of 6.165, 16526 times 10 to the 14th hertz. And then you're going to use that and 11C to find lambda, because we know lambda equals C over F. And when you do that, so 2.9979 to the 8th divided by that F, you get 4.86257 times 10 to the negative 7 meters. And I know I'm skipping steps, but these are all the same. Then we go to D. And D wants the energy of a photon going from 2 to 5. So E5 minus E2, and E5 was, I lost the numbers, negative 0.544 electron volts, minus 2 was negative 3.4 electron volts. So EP is equal to 2.85 electron volts. Then you use that to find frequency by doing E over H. And when you do, you get a frequency of 6.905 times 10 to the 14th hertz. And then you use that to find lambda, C over F. And when you do, you get a lambda of 4.34158 to the negative 7. So I did these all like in one step, so there's no rounding here unless I screwed up. And then the last one is E5 minus E3. So it's going from 3 to 5. So 5 was the negative 0.544 electron volts, and 3 was the negative 1.51 repeating. And so you get an EP of 0.967, I think that's 1 repeating if I can make out my handwriting. So then you find F by doing E divided by H, and you get 2.33823 times 10 to the 14th, and then you use that to find lambda, C divided by F, and you get 1.282123 to the negative 6 meters. Okay, so they probably could have only given you like 3 of those. That was a little painful to do all of those. All right, so that was number 11. Number 12 says, find the question again. Determine the frequency and wavelength of a photon emitted when an electron drops from 3 to 2 in the hydrogen atom. Okay, so EP, so this is 12A. EP is it drops from 3 to 2, so 2 is the final, 3 is the initial. We already found E2, it was negative 3.4 electron volts. We already found E3, it was 5.11 electron volts. So when you do this, you should get an EP of negative 1.8, and the 8's repeating electron volts, and the negative means emitted. So that's part A, and then part B wants the frequency. Or maybe actually it wants the wavelength in the end. So you're going to do exactly the same steps. F is equal to E over H. And you can drop the negative now, it just meant emitted. 1.602 to the negative 19 joules per electron volt. divided by 6.626 to the negative 34 joules seconds. So this time they didn't break it into steps, they put it all together, but 56686, but it's exactly the same procedure. And then lambda is equal to c over f, and when you do that, 6.56447 to the 7th meters. Okay, so that's for part A. Part B says same thing, but this time it's going from 4 to 3. Okay, so for B, EP is equal to E3 minus E4. So EP is equal to 3 was negative 1.51 repeating, minus 4 is negative 0.85. So EP is equal to negative 0.66 with the 1 repeating. And again, the negative means emitted. And then we do exactly the same steps again. F is equal to E over H. And when you do this, you get 1.584 to the 14th hertz. And then you do lambda equals C over F. And you get 1.87556 to the 6th meters. 12 is done. Okay? Sorry, like 11. Yeah, you probably did these enough now that it should be cemented in your head.